The purpose of this video is to answer question 6 on page 183 of our Applied Mathematics book. The question states, how many barrels will the tank in the sketch below hold? As we examine the tank, we can see that it is basically one cylinder in the middle with a hemisphere on each side. The tank is 28 feet long with a diameter of 14 feet, while each hemisphere has a radius of 7 feet. The best way to attack this problem is to separate the cylinder from the hemisphere on each side. Once separated, each hemisphere can be combined to form a sphere with a diameter of 14 feet. The next step is to find the volume of each individual figure. To get the volume for the cylinder, use the formula V equals pi times radius squared times height. Then plug in the data from the problem and solve. The total volume for the cylinder is 4,310.27 feet cubed. Next, find the volume of the sphere. To get the volume, use the formula V equals 4/3 times pi times radius cubed. Then plug in the data from the problem and solve. The total volume for the sphere is 1,436.76 feet cubed. Once both volumes are found, add them together to get the total volume of the tank in feet cubed. This total is 5,747.03. This final volume isn't the correct answer because the problem asks for the total in barrels. So we need to convert the feet cubed into barrels. To do so, use the amount of barrels in 1 cubic foot, which is 0.178 barrels. To convert the units into barrels, simply multiply the total in cubic feet by 0.178. The product is 1,022.97 barrels, which is the final answer to this problem.